I'm Raghavendra, that's Lihang, Mondi, and Matt. Our project deals with the design of an electronic mobility aid for the visually impaired people. So our inspiration for the design of such a product originates from two levels. Firstly, on a global level, we have sort of investigated certain statistics with regard to the number of blind people. And as displayed over there are about 300 million blind people in the world, of which 3/4 are senior citizens. There are a number of problems that these people face, and particularly with regard to senior citizens, because of their less visual acuity and because of their less dexterity, they suffer from many falls, and consequent to these falls, they suffer from many psychological and physical imbalances which would not enable them to recover easily. And secondly, our personal experience in observing other people handling the mobility devices also reveals that these devices do not actually cater to the section of people like elderly people with visual impairments, because they can't grip them properly, and because of certain other needs. So we have structured a problem to be a design of a device that would help the visually impaired people get a better perception of their environmental hazards. So as we have done our market research, there are three popular categories of mobility aids in the market right now. Firstly, the state-of-art devices. These are the devices which are being developed in different research laboratories, and they boast of pretty advanced features such as the use of GPS in case of eye cane and the use of 3D imaging sensor in case of smart cane. But again, these products face certain drawbacks in the sense that they are very complex to their use, they are not so intuitive, and moreover, these products are also highly priced. Secondly, there are certain commercially available devices and canes, and even these require considerable amount of practice, and they are either very sophisticated and costly, or they are very less sophisticated and probably do not help the visually impaired people much. And they are very physically demanding, and also they are not designed for the particular demographic of age population. So there are also certain other stigma, such as social stigma and the long practice period associated with traditional mobility aids. So in our framing of design objectives, we have taken into consideration these details, and the design objective would be elaborated by Liam.
Thank you, Raghu. Okay, so before we set out to design the actual device, we looked at some already existing devices to see like their shortcomings and strengths, and why they may not be good for our target market. And we also did a lot of market research. So we made contacts with experts in the field. We conducted market polls, and we got in touch with the retirement homes. So we came up with these 6 design objectives, and I'll just go over them briefly. So the first one is covertness. So that means, as Raghu talked about, there's a certain social stigma associated with the use of a cane for the elderly. So you want it to be very covert, so that others will not see the person using it. Second one is intrusiveness. So that means the device has to be very comfortable for the user, and it cannot change their daily habits. Third one is intuitiveness. So a lot of senior citizens, they're not good at learning new things. So it has to be very easy to use and easy to learn. Fourth is dependability. So people are going to be trusting this device to take care of themselves. So it has to be dependable to detect environmental hazards. And then there's reliability, so it can't break while using it. And then the last one is, of course, cost, which is always a inhibitor to introduction of new technology. So we came up with a design that's it right there. So basically, it's a shoe-mounted series of sensors. So there's 3 basic active sensors. First one is an ultrasonic sensor that points forward. So if I'm walking forward and there's an obstacle or a ledge, it warns me. The second sensor is another ultrasonic sensor that points downwards. So if I'm walking over a ledge, it tells me, so I have to step down, I don't trip. And then the third one is the accelerometer, which basically detects planar motion between the shoe and whatever surface you're on. So it tells you if you're slipping. And all 3 of those are fed back using vibration motors mounted here and here, depending on which kind of hazards that you encounter. So next I'll hand it over to Matt.
So our plan for development is to
build and test a series of prototypes. There's several systems. We have a suite of sensors. Like I said, a microcontroller. Need to work to calibrate those sensors to work in different environments on different surfaces, asphalt, carpet, tile. Integrate the sensors to get them working with a microcontroller. And then there's a user interface aspect, which is the part that is demonstrated by our prototype. How it's going to actually fit on the shoe, how well that will interact with the users, whether they'll like it in two parts the way we have our concept that we're going with, or if it needs to be more compacted. So we're going to go through a series of prototyping those, build a functional prototype, and then actually get some trial usage out of it with volunteers or actual blind participants, and integrate that feedback into a final product.
In conclusion, some of the challenges that we might encounter are calculating pretty much the position and sensitivity of the sensor, so it doesn't give false positives. Also, another challenge is creating the device small and light, so it's not intrusive to the person. Another challenge is that to make the device easy to easily wear, so it becomes like a second nature to put the device on. And the last challenge, which is the most important, is to finish all of the above in the required time and the budget.
Thank you.
Are you guys worried at all about multiple sensors triggering at the same time?
That's a very good question. So you see this thing in the back. That basically, I'll just go into a little bit of detail about it. It has like a sensor there, not a sensor, a speaker. So this sends out a pulse to the back, and when this thing hears this, it basically doesn't listen. So if you're like this thing sends out a pulse to the back, and then so that one doesn't interfere.
Okay.
Yes.
Have you done any tests to see how much time people need between the alert, and how much time do they need to adjust to intervene before they fall over?
That's hard to quantify. I mean, it depends on the user. I mean, for elderly, it'll probably the sensor will probably be faster than the reaction time. Versus you and me, if our feet slips, then we know to react. But for them, it's like slower. So, yes.
I know for the elderly, comfort is like one of the biggest feeling aspects. So how comfortable is that sticking in the back? So
It's pretty comfortable. You can't feel it.
like how you can get like quote-unquote shoe bites with certain types of shoes because it rubs up against the back.
Yeah, but that's because of the friction. Depending on the material, we can just make it like a material that just doesn't give like much friction. That's easily taken care of.
Plus, we don't really need this thing. You can just use the band, but it's just kind of an initial prototype.
Okay, who hasn't asked the question yet? Ali, you haven't asked yet. Go for it.
Do I have to?
Yes.
I was thinking about the cost, how much it would cost mass production.
So we are planning that it would cost like something about 200 to 50 for the prototype, and in case of mass production, we expect the cost to come down to about around $150. So that was $150. That would be pretty competitive with regard to other products.
Yes.
So would you expect a user to buy one of these then and move them to each individual pair of shoes?
That's one of the questions that we're asking. So I think for elderly people, they usually wear like one pair of shoes for walking. So, but it's very easy to.
Yeah. And also, well, I was gonna say that we can even manipulate like the tips so it's movable and it can fit any kind of shoes. And work out.